All right, welcome to class, everybody. Today's lesson is our first lesson in Unit 2. So as a reminder, the Unit 1 test is available in the testing center today and tomorrow. It was also available yesterday if you took it yesterday. And also as a reminder, any assignments before today have to be submitted by Friday. So if you have any late work from Unit 1, make sure you get that submitted by Friday because you won't be able to use late passes after Friday. On the Unit 1 stuff. You'll still be able to use them on Unit 2 and stuff though. Okay, so our first section in Unit 2 is section 5.1, which is about adding and subtracting polynomials. So before we add and subtract them, let's just talk really quick about what a polynomial is. So a polynomial is a mathematical expression. So notice that it's not an equation because it's not equal to something else. So it's kind of like it's part of a math sentence, but it's not a full math sentence. So a polynomial is an expression where you have variables that have differing exponents, like you have an x cubed term, an x squared term, an x to the first term. Usually we don't write the 1, but you could if you wanted to. And technically you could also write x to the 0 on this term because anything raised to the 0 is 1. And so this is the constant term. So you have variables with different exponents, and then the numbers that are multiplied by those variables are called coefficients. And then we have terms, which are basically the variables and their coefficients together. So this polynomial has 4 terms. And then the way that we describe an entire polynomial to kind of like tell what type of polynomial it is we look at the degree, which is the largest exponent in the polynomial. So in this case, this polynomial would have degree 3 because the x cubed is the largest variable in there. And then the leading coefficient is the coefficient that's multiplied by the variable to that largest exponent. So in this polynomial, the leading coefficient would be the number 4. Do you guys have any questions on that vocabulary? Okay, let's practice it really quick. So in this polynomial, what is the degree of it? Raise your hand if you know. I think I heard someone say it. Yeah. Yep, it would be 8 in this case because that's the largest exponent. And what would the leading coefficient be? Yep, it would be 6 because that's the number that's multiplied by the term with the largest exponent. Now, typically, we don't write polynomials like this because it's kind of a standard practice to write it in order from largest to smallest exponent. So it's more likely that you would see a polynomial written like this because that would be in decreasing order of the exponents. But even if it's written out of order, the degree of the polynomial is still the largest exponent in the polynomial. Okay, what about this one? What would be the degree of this polynomial? Yep, this one would be 0 because we could write this as 7 times x to the 0 because anything to the 0 power is always 1. And since we only have a single term in this polynomial, just the number 7, which you could write as times x to the 0, that means that the exponent for that term would be the degree. What would the leading coefficient of this polynomial be? Yep, it would be 7. Okay, so that's just some vocabulary for polynomials. A couple more terms for polynomials. Some polynomials they have like special names based on the number of terms. So a monomial would be something like x or 3x squared or 5 or anything that just has a single term. A binomial is a polynomial with 2 terms. So you could have like x minus 5 or x squared plus 3x or 5 minus x cubed or something like that. These would all be examples of binomials. And then a trinomial, I'm sure you can guess, is a polynomial that has 3 terms. So it might be something like x squared plus 3x minus 5 or anything that is going to have 3 terms in it. And that just comes from the root word. So like binomial is like a bicycle with 2 wheels. The root word bi means 2. And so you have 2 terms in your polynomials. Tri, same thing, like a triangle has 3 sides, a tricycle has 3 wheels. The root word tri means you have 3 terms. Any questions about that? Okay. So when you're working with polynomials, there's kind of like 2 different ways you can think about it, and we'll be doing both in this class. So the first way is you can think about it as a function where the x's or the variables in the polynomial represent some number. So what we'll talk a little bit more about functions. So this is kind of like a little preview of it. But the idea of a function is that you take something and you input it into a function. So we usually use the letter F to represent a function. And the output of that function is going to equal all of this stuff that you do to x. So if they ask you to find the function of -3, then that basically means you need to find the output when you input a 3 everywhere in x's. So this is called evaluating a function. And you would basically just simplify that until you get a single number. So like you'd start off, because of order of operations, you'd start with the exponents, and that would give you 6 times 9 minus 2 times -3 plus 8. Then the next order of operations is multiplication. So you do 72 plus 6 plus 8, and it's plus 6 because you have a -2 times a -3. And then you just add all those together, and I think that would give you 86. Whoops. So f of -3 in this case would equal 86. Yeah. Oh, it is. Yes. Thank you for catching that. 54. That would give us 68 then, right? When we add them together. Thank you for catching that mistake. Yeah. So that's how you can evaluate a polynomial when you're thinking about it as a function. So that's like kind of thinking about x's as basically being unknown numbers. Now, another way that you can think of polynomials, and this is actually the way that they're often used in advanced math, is to think of them as being placeholders. So we're not necessarily like saying like, oh, what is x, or x is like a specific number. We're rather thinking about these as placeholders. Kind of like, you know how like when we started learning math in like elementary school, how it's like, oh, the numbers in the ones column represent 1, 1, but the numbers in the tens column represent like that number of tens and the hundreds and the thousands, and you know how like you have the place value thing. So polynomials can be thought of in a very similar way. And it is kind of helpful when you're adding and subtracting them, but it becomes really helpful to think about them that way when you multiply and divide them. So I'll kind of come back to this once we get to multiplying and dividing polynomials, but I just wanted to kind of mention it because it can be a helpful way of thinking about that. And I think it's also kind of interesting because like if you make like a x to the 0 column, and x to the 1, and x squared, and x cubed, and x to the 4th, and so on. Like if you think about them as being place values, technically that's what our place value is as well. It's just instead of having x's, we have tens. You know, like 10 to the 0 is the ones column. 10 to the first column is the tens column. 10 squared is the hundreds column. 10 cubed is the thousands column. So it can be kind of helpful to think about that. And you can use that when you're adding and subtracting them. So let's say, for example, we have this polynomial plus this polynomial. Well, if you thought about them as being place values, you could say, well, I have -4 in my x squared column, a -2 in my x column, and a +5 in my constant column. And then I have an x squared that I'm subtracting, and a +7x that I'm subtracting. And when I subtract those, that one becomes negative and this becomes negative, leaving me with 5 negative x squareds, 9 negative x's, and a +5. So this is one way you can think about it as like place values, because essentially you're just adding the place values together. But you can also do this by just getting rid of the parentheses and combining like terms. And that's usually the way that I add and subtract polynomials. But the place value way, like I said, is really helpful when you're multiplying. So The other way that you could do this is you could say, well, this set of parentheses has a positive 1, essentially, that's being multiplied by all of it. So if I distribute that, that would just give me negative 4x squared minus 2x plus 5. And then on this one, I have a negative 1 that's being distributed to everything in the parentheses. So I'd have negative x squared minus 7x. And if I combine my like terms, negative 4x squared plus a negative x squared would give me the negative 5x squared. Negative 2x's plus negative 7x's gives me negative 9x's, and then I have the plus 5. And you can see that answer is the same that I got with my place value method. So you can kind of just choose whichever way you like the best. For adding and subtracting, I think I like this method the best. But if you like this, you're welcome to use it. So any questions on adding and subtracting polynomials? Okay. If you do decide to use this method that I did in blue, just make sure that you always distribute what's outside of the parentheses to everything inside of it. So since I had a negative 1, it's not just minus x squared, it's also minus 7x as well. So you have to make sure you subtract all of it. And sometimes I think there's one problem on your homework where it's a rather complicated expression that you're asked, like a whole bunch of polynomials that you're asked to add and subtract together. So if you get something like this, you basically want to start on the innermost set of parentheses and work your way out from there. So on this one, I have these two sets of parentheses, and they are inside of a bigger bracket or a bigger set of parentheses. So I would start by simplifying these little ones first, and I distribute the negative to both of these, which gives me negative x plus 8. Then I distribute the negative 2 to both of these, which gives me negative 6x minus 12. All of that stuff is still inside of the big set of parentheses, so it's multiplied by negative 5. But then I could simplify this stuff inside of parentheses because I have a negative x and a negative 6x, which I could combine together to have negative 7x's. And then 8 plus a negative 12 would be negative 4. And then, I mean, you don't have to do that before you distribute the 5, but I think it makes it easier because then you don't have to distribute it to as many things. So then you do negative 5 times negative 7x is 35x, and negative 5 times negative 4 is positive 20. And so this expression is the same expression as this. It's just a simplified one. Kind of like how like 3/6 is the same thing as 1/2. They both mean the same thing, but 1/2 is a more simple version of it. So you'll have some problems like this. And then you have a bunch where you're just adding and subtracting the polynomials together. And to summarize everything we talked about, the definition of a polynomial is a whole bunch of terms that are added together. Each term has a variable with an exponent and a coefficient, which is the number multiplied by it. And the degree of the polynomial is the largest exponent. And the leading coefficient is the number that's multiplied in the term of the leading or of the largest exponent. Yeah, I think if I haven't written the test, but from what I remember from last unit, I think I did ask for the degree on the test. And I can't remember if I let them use a note card or not, but maybe ask me when we get closer, because that's not the type of thing I would put on like a formula sheet. But I think I can't remember what all is on the test, because I think I might let you guys do a note card on the second one. But ask me when it gets a little bit closer, because I can't remember at the moment. Yep. So those are the definitions you need to know for a polynomial. When you're adding and subtracting, you can either do it by combining like terms, which is my favorite way to do it, or you can also think about it with the place value method. If you're asked to evaluate functions, that's where you're thinking of x as being a number, and then you substitute that number in for all the x's. So that's called evaluating a function. And then monomials have one term, binomials have 2, trinomials have 3 terms, and polynomial means you have many terms. So that's pretty much everything you need to know for your homework. I'll go over, I think it was question 5. because this one has fractions. But if you guys want to open up your computers and go to question 5, I'll do that in just a minute. All right, so on question 5, I'm going to do it by combining like terms because I like that method. But the one thing to remember here is that a polynomial is not an equation. It's just a single math expression, but there's no relationship to another math expression. Because remember, an equation means you have like some stuff equals other stuff. But in this case, we're just asked to simplify a single expression, which means that we can't get rid of the fractions the way that we did when we were working with equations, because there's no equation to multiply both sides by. And if I multiply the expression all by itself, then it's not going to be the same expression anymore. So that means that we really can't avoid working with the fractions. And when we combine the like terms, we're going to have common denominators. So before I do that, I'm first going to distribute all of my parentheses out. So when I multiply a positive 1 times everything in the first set of parentheses, I get negative 1/4 y squared plus 1/6 y plus 1/4. And then when I distribute a negative 1 to everything in the second parentheses, because I'm subtracting that polynomial, I get a positive 1/12 y squared, a negative 1/2 y. And then when I distribute this positive 1, I end up with a negative 1/12 y minus 1/6. So now I need to look at what I want to combine. So I'm going to start with my y squared terms, which are these two terms. And if I have negative 1/4 and I'm adding 1/12, I need to follow the rules for adding fractions, which means I have to have common denominators. So I'm going to multiply the top and the bottom of this fraction by 3 so that I have common denominators of 12ths. So that's going to give me negative 3/12 y squared. And that will match the 1/12 y squared here so that I can combine those terms. I'm also going to need to combine my y's. And it looks like I have a denominator of 6, 2, and 12. So my common denominator would be 12. So I'll multiply this by 2/2, which gives me 2/12 y. And that's a positive. And then on this one, I'll multiply the top and the bottom by 6, which gives me negative 6/12 y. And then this one is already in 12ths, so I don't need to do anything with it. And then for the last one, I just have my constants of 4 and 6. And the common denominator for those would be 12 as well. So I'm going to multiply the top and the bottom by 3, which gives me 3/12. And this one gives me negative 2/12. Now, in this case, all of the denominators ended up being 12s, but they don't necessarily have to be, because the only things you're adding together are like the y squareds and then the y's and the constants. So like if you had, like if this had been 1/4 instead of 1/12, you wouldn't have had to like change these to be 12s because they would have already had common denominators. Yeah. Good question. So it's because it's not an equation. So like if you had all of this stuff equal something, then you could totally multiply both sides because it would keep the equation constant. But in this case, it's just a single expression. So it's kind of like, so like if we went like super simple and we said like 2 = 2. Well, I could multiply both sides by like 4 or something, and I get 8 = 8. The equation is still true, even though the numbers are different. But if I'm just dealing with a single number and I have a 2, I can't just say, oh, well, I want to multiply it by a 4, so let's just make it an 8, because then it's not showing that it's equal to. Yeah, good question. Okay, so then once you've got common denominators for each of your terms, then you just combine them. So negative 3/12 y squared would, when you add it to 1/12 y squared, you would get negative 2/12 for your y squared term. And then for your y term, you have 2/12 minus 6/12 minus 1/12. And I think that should give you negative 5/12 y. And then for my constant term, I have 3/12 minus 2/12, which is 1/12. And in this answer, I could actually simplify the 2/12 to be negative 1/6 because that fraction can be reduced. And that would give me this answer. And so this would be my solution to question 5. So the main thing is just that, unfortunately, we can't get rid of fractions when you're simplifying polynomials because it's not an equation. But if you had a polynomial that was equal to something, then you totally could get rid of the fractions if that would be helpful.